Good morning, ma'am. Today we are here for our presentation on the topic Eulerian graph. My name is Mehuli Bashu, roll number 80. So, graph definition. A graph is a non-linear data structure and it is made up of set up of vertices and edges. A graph can be depicted as a set of dots or a circle of the vertices or joined by the lines or curves for the edges. So, types of graph. There are three types of graph: simple graph, directed graph, and isomorphic graph. Simple graph, a graph with no loop, edges joining the same vertex, and no two edges joining the same pair of the vertices. Directed graph, a graph with edges that are recognized to be ordered. An isomorphic graph, a graph that are basically the same, or better yet, if they are the same except for the name of the vertices. Key points related to graph. Vertex. A point is in a graph is called vertex. A line or arc that connects two vertices is in a graph is edge. A sequence of vertices connected by edges is called path. A path that starts and ends at the same vertex is called cycle. A graph where every pair of vertices is connected by a path is called connected graph. A graph formed from a subset of another graph's vertices and edges is called a subgraph. The number of degrees that connects to a vertex is called the number of edges that connects to a vertex is called degree, and the matrix that represents a graph using zeros and ones is called adjacency matrix, and an array of linked lists that represents a graph is called adjacency list. Introduction of Eulerian graph. An Eulerian graph is a closed walk that visits every edges of a graph exactly once and return to the starting vertex. A vertex A vertex has an even degree if there are even number of edges connected to it. A graph is connected if all its vertices are connected by edges. The term Eulerian comes from an Leo, Leonard Leonard Euler's consideration of whether the bridges of the introduction of Eulerian graph. An Eulerian graph is a closed walk that visits every edges of a graph exactly once and returns to the starting vertex. Introduction of Eulerian graph. An Eulerian graph is a closed walk that visits every edges of a graph exactly once and returns to starting vertex. A vertex has an even degree if there are even number of edges connected to it. A graph is connected if all its vertices are connected by edges. The term Eulerian comes from the Leonard Euler's consideration of whether the bridges of Königsberg could be crossed in this way. Now, I'll be passing the presentation to Mohit. Cut.
My name is Mohit. Let me begin with the examples of linear graph. Example 1. In the following graph, we have 6 nodes. Now we have to determine whether this graph is an Euler graph. We seen in the diagram solution. If the above graph contains a Euler circuit, then it will be Euler graph. A graph will contain a Euler circuit if the starting vertex and end vertex are the same. And this graph visits each and every edge only once. So when we begin our part from vertex A and then go to the vertex E, D, F, B, C, D, and then A in the process. The starting and end vertex are the same. So this path covers all the edges only once and contain the repeated vertex. So this graph contains the Euler series, hence it is a Euler graph. Example 2. In the following graph, we have 5 nodes. Now we have to determine whether this graph is Euler graph or not. Solution. If the above graph contain the Euler circuit, then it will be an Euler graph. So when we begin our part from the vertex A and then go to the vertex B, C, D, and B and E, then A in the process the starting and end vertex are the same. This part covers all the edge only once and it contains the repeated vertex. So this graph contains the Euler circuit, hence it is an Euler graph. Third example. In the following graph, we have 8 nodes. Now we have to determine whether this graph is a Euler graph or not. Solution. If the above graph contains the Euler circuit, then it will be an Euler graph. A graph will contain an Euler circuit if the starting vertex and end vertex are the same. And this graph visits each and every edge only once. So if we begin our path from vertex A and then go to the other vertex and then A, then in this process the condition of the same starting and end vertex satisfies. But another condition of cover all the edge only once is not satisfied. So when we follow the path, then we got the A put 2 times. So in this process, many edges are not covered: A to E, G to H, F to B, and D to C. which violates the definition of Euler circuit. So the above graph does not contain a Euler circuit, hence it is not a Euler graph. Now I am going to cover the properties of Euler graph. Point 1. Connectedness. The graph must be connected. All the edges of the graph must be connected. Vertex degree. In the Euler graph, each vertex must have an even degree. Euler path. If a graph has more than two vertices of odd degree, it has no Euler path. Point 4. Euler circuits. If a graph is connected and has zero or exactly two vertices of odd degree, it has at least one Euler path. Fifth point, tracking. A graph can be tracked if you can start at an edge and draw the entire graph without lifting your pencil or going over an edge twice.
My roll number is 82. I'm continuing with application of Eulerian graph. Here are five application of Eulerian graph. First one, network routing. Second one, circuit design, traffic flow, GPS navigation, logistic and supply chain management. Network routing. Eulerian graph are used to find the most efficient route for network routing, such as in techno communication and transportation system. Second one, circuit design. Eulerian graph are used to minimize the number of wire and optimize circuit design in electronic circuits. Third one is traffic flow. Eulerian graph are used to model traffic flow and optimize traffic light timing to minimize congestion. For one, GPS navigation. Eulerian graph are used in GPS navigation system to find the shortest path between two locations. Logistic and supply chain management. Eulerian graph uh, are used to optimize route for delivering trucks and supply chain management. Euler path. We can also call the Euler path as Euler walk, Euler trial. If there is a connected graph with a trial that has all the edges of the graph, then that type of trial will be known as the Euler trial. If there is connected graph which has a walk that passes through each and every edge of the graph only once, then that type of walk will be known as the Euler walk. Now examples of Euler path. Example 1. In the following image, we have a graph with 4 nodes. Now we have determined whether this graph contains an Euler path or not. Solution. The above graph will contain the Euler path if each edge of this graph must be visited exactly once, and the vertex of these can be repeated. So if we begin our path from vertex B and then go to vertices C, D, B, A and D, then in this process each and every edge is visited exactly once, and it also contains repeated vertex. So the above graph contains an Euler path which is described as follows: Euler path BCD BAD. So the path. Now Nandini, continue. Here's example second. In the following image, we have graph with 6 nodes. Now we have to determine whether this graph contains an Euler path. Solution. The above graph will contain the Euler path if each edge of this graph must be visited exactly once, and the vertex of this can be repeated. So if we begin our path from vertex B and then go to vertices C, D, F, B, E, D, A and B, then in this process each and every edge is visited exactly once, and it also contains repeated vertex. So the above graph contains an Euler path which is described as follows: Euler path B C D F B E D A B. Now my friend Nandini, continue it.
Hello everyone, I'll continue with the topic Euler circuit. If there is a connected graph with a circuit that has all the edges of the graph, then that type of circuit will be known as Euler circuit. If there is a connected graph which has a walk that passes through each and every edge of the graph only once, then that type of walk will be known as Euler circuit. In this walk, the starting vertex and ending vertex must be the same, and this walk can contain the repeated vertex, but it is not compulsory. If an Euler trail contains the same vertex at the start and end of the trail, then that type of trail will be known as Euler circuit. A closed Euler trail will be known as a Euler circuit. Next slide we have Examples of Euler circuit. In the following image, we have a graph with 6 nodes. Now, we have to determine whether this graph contains the Euler circuit or not. The above graph will contain the Euler circuit if the starting vertex and end vertex are the same. And this graph visits each and every edge only once. The Euler circuit can contain the repeated vertex. So, if we begin our path from vertex A, then go to B, C, D, F, B, E, D, and then A. In this process, the starting and the end vertex are the same. The path A, B, C, D, F, B, E, D and A also covers all the edges only once. And it does not contain any repeated vertex except the starting one. So the above graph contains an Euler circuit, which is described as follows. From the above diagram we can obtain that A, B, C, D, F, B, E, D, A. Now for the last topic, we need to remember the important points to verify a graph. The important points are, if there is a connected graph with an Euler circuit, then that type of graph will be an Euler graph. If there is an even degree for all the vertices of the graph, then that type of graph will be an Euler graph. If more than two vertices contain an odd degree, then that type of graph will be an Euler tree. Otherwise, it will not be an Euler tree. Thank you for watching.